Hi everybody, welcome to this episode of Simply Sterile. I'm your host Carol Malone, and today we are going to be talking about chemical indicators, specifically the 6 classes of chemical indicators. Now, I want you all to kind of know that here's your ANSI AAMI 2017, where I'm getting the information from. So if you look at page 78, I go from page 78 to probably about page 80, 81 or so. So if you want to look at that information after you see the presentation, please by all means reference your AAMI ST79. So with that said, the first thing I want to go over is there are 6 integrating indicator types, variable indicators. So I'm going to focus mostly on steam products today. So there are 3 parameters to steam sterilization: time, temperature, steam under pressure. So these indicators are reacting to 1, 2, or all 3 of those parameters: time, temperature, steam under pressure. So your class 1 is your exterior steam tape. There's many different brands on the market. There's the cream colored, there's your green color. So there's different colors of tape, but they start out one color. Once they've been exposed to sterilization, they are reacting to being exposed to temperature or heat. So this will turn from cream to black, so the stripes will turn black. So that's a visual indicator to me that this type 1 indicator has reacted to one of the 3 parameters for steam sterilization. So that's my first indicator that the package was either unsterile, such as this one, or sterile, such as this one. So the second type of indicator is a class 2, and typically a class 2 is used for specific test procedures, and a class 2 would typically be your Bowie-Dick or your DART test. So DART stands for Daily Air Removal Test. So this is a procedure that is being done in your sterilizer. So a Bowie-Dick or DART test is also a process challenge device. So when you open these up after, first, I know this has not been exposed to sterilization because this yellow dot, or this class 1, is still yellow. Once it's been exposed to sterilization cycle, this dot turns black. So again, it's my first visual to know that this has or has not been exposed to a sterilization cycle. So once I open it, I see all these cards in here. These are my challenge. This is my challenge. So there's a foam in here. There's all these thick cards. So what happens is it's challenging for the steam to get through here. So again, the circle is yellow. Had it been exposed to sterilization, this circle will be black. And the other card in here should also be yellow, and it is. So once this entire pack has been exposed to sterilization, these lines should all be perfectly black. If there's any variation, any weirdness, any fluctuation in colors, that's an indication to me that my sterilizer is not functioning properly. So I would want to rerun the test at that time, but I just wanted to show an example of the type 2, and also this is a process challenge. So, moving to your class 3, I don't have an example of a class 3. A class 3 is a chemical indicator that's designed to react to one of the 3 parameters. The 3 parameters again: time, temperature, steam under pressure. So a class 3, I will look up a copy of a class 3 and post a picture of it so that you know what they look like. Same thing with the class type 4. I do not have an example. I will post a picture of it. Typically the ones I've seen are kind of long like this, more of a paper, and those can be used in some sterilization cycles. Just make sure you look at your IFU and see that it's validated for a class 4 chemical indicator, because the class 4 is designed to react to 2 or more of the parameters of steam sterilization. And again, the parameters are time, temperature, steam under pressure. So I have an example here of a peel pack that has been sterilized. So just to kind of give you an example, my first visual is that this tape has been exposed to one of the three parameters because these lines were cream colored and they are now black. So that tells me that this package has at the very least been exposed to heat or temperature. My second indicator that this has been sterilized is that these diamonds on this internal card, which is another visual for me, have changed to black. And my third indicator is that my class 5 indicator right here has changed from white to black into the window where it says it is acceptable. And then of course, I do also see a load sticker, and I would of course look at the tape on the sterilizer, and if there was a biological, incubate the biological, and so on. So again, it's a lot of visual indications of that sterilization has occurred. So that kind of got ahead of myself, but the type 5 indicator, there's several brands on the market. There's this one, some of them have tails so that you can find them. There's this green and red one. There's this blue and white one. They're pretty much a window. Once it's been exposed to the time, temperature, steam under pressure, these windows will go from white to black, and it has to go all the way across into the acceptable range. So these are reacting to all three parameters. And again, it doesn't, whatever your facility uses, these are just some examples that I had to show you. So those are equal to or exceed the requirements for a biological. So these are pretty much the industry standard as your type 5s. Now a type 6 indicator is designed to react to critical process variables. So for example, some of you may or may not have ever seen this. This is called a success pack. This is a type 6 chemical indicator, and it's for a specific sterilization process, and that process is, it's for steam flush pressure pulse sterilizers running a 270 cycle for 4 minutes, which is a pretty standard cycle. However, we all know we have instruments that require 5-minute exposure, or some of your dental and eye things, require 5, even 10-minute exposure. So this would not be for those cycles, anything other than a 4-minute exposure cycle. But this is an example of a class 6. So just to review, class 1 is your external tape, exposure to one of the 3 parameters. Your class 2 is typically a test of some sort. Your classes 3 and 4 are designed to react, class 3 is designed to react to one of the 3 process variables. Class 4 is reacting to 2 of the 3 process variables. Class 5 is reacting to 3 of the class 3 variables. And then your class 6 is reacting to specific cycles. Well, I've completely confused you. Again, refer to your ST79 book, page 78, 79, and 80. Kind of goes into a little more detail. The other thing I kind of wanted to just touch on, if you look at page 81, is process challenge devices, or PCDs. So what typically process challenge devices, this particular brand, they can contain a BI or a BI and a chemical indicator class 5, or like this process challenge device contains a class 5, and then it's got all the cards inside of it like your Bowie, so that it is challenging the sterilization of this indicator inside of it, again, PCD, process challenge device, to ensure that sterilization is occurring. Or a class 6 would also be a process challenge device. Again, I'll put a picture up of what this looks like, sterile and unsterile. It kind of looks like your Bowie. It's got the cards in it and so on, and the sheet that changes from yellow to black. So those are, and this particular item, this plastic is considered the challenge. So it's more environmental friendly without all the papers. There's a tiny little, I call it a straw, that's where the steam gets in, and then this is what causes the challenge because the steam has to go in this tiny little hole. So there's a lot of things to know as far as integrator types, process challenge device, all the visual cues to know that an item is sterile or not sterile. Always refer to your manufacturer's instructions for use on any products that you use, on the sterilizer that you're running, and the process of the instruments that you're sterilizing. So there's a lot of directions to read and follow, but I know you can do it. Well, that wraps up all I have to say today, so thank you for tuning in. Take care. It's your payday. Sterile Processing technicians.